So let's look at what machine, introduction to machine physics. So here we want to talk about what is machine, common terms and formula associated to all type of machines. They want to talk about some basic questions. So this is going to be the first part of machine series. So you want to stick to the end of this video here because this very particular video here will help you to understand the concept of machine. That will help you to understand every other thing in machine. Do you understand? So what is machine? A machine is any device or tool that is used to overcome a force or load by the application of a force, which is effort, at a point. So when we talk about machine is any simple device or tool that you can use to overcome a large load by the application of effort. So the essence of a machine is to apply a small effort in order to overcome a larger load. Do you understand? So the essence of machine is to make things work easier for us. Do you understand? So for example, here we have wheelbarrow. If for example now you want to carry a cement with your head, now it requires a lot of energy and effort to carry that one to where you want to go, right? Now, but if you apply a wheelbarrow and you carry that cement to the wheelbarrow, right? What you want to do here is to just apply a small effort in the wheelbarrow and roll it, right? So that is the work of machine. And we have different type of machine. We have what we call the screw jack. We have what we call the inclined plane. For example, now you want to carry a load to some certain height. Now, if the load is very heavy, now what you just need is just an inclined plane that can help you to push it with little effort here. Do you understand? So the essence of a machine is to make our work easier for us by the application of what little what effort. That is the essence of a machine. So in the sense that the load should be far higher than the effort. Just that if the load is 800 Newton, now the effort should be like 100 Newton, do you understand, or 50 Newton. So the essence is that we want to overcome a large load by a little amount of effort. So any machine, any device or tool that will help us to overcome a larger load with small amount of effort is called what? Machine. Do you understand? So please get the concept clear. Do you understand? There are three terms common to all type of machine. So the first one is called mechanical advantage. So here we have mechanical advantage. I use called MA. Now, mechanical advantage is also known as what? Is also known as what? The force ratio. And here we have which called MA. MA is always equal to what? Load over what? Effort. Load over what? Effort. Now this load is what? Force. Do you understand? Now another thing here is that now we have called force input and force output. So there are two things you want to know here. Force input and force output. Now force input is what you are putting in. It's called what? The effort. It's called what? The effort. Force output is the force you are overcoming. Do you understand? Which is called what? The load. So you have to break those things of this here. So now the reason why it's called force ratio, now because mechanical advantage is not about force ratio because it's force ratio force. Now, but one force is the load, while the other force is what? Is effort. Do you understand? So yeah, load is also the center what? Force what? Output. Over what? Force what? Input. So these are things you need to take note of here. So when talking about mechanical advantage, what? Load by effort. We also the center what? Force output, because this is what you are overcoming. Then force input, which you call the effort. This is what you are putting in to overcome what? Load. So you are putting in effort, which is what? Force input, to overcome the load, which called the output. Do you understand? So that's the first thing you want to take note of here, the mechanical what? Advantage. Now, remember I tell you that mechanical advantage is also our force ratio. Force what? Ratio. Do you know the reason why it's called force ratio? Because force output over what? Force input is called force what? Ratio. Now the next thing you want to look at is what is velocity what ratio. Number 2, velocity what ratio. I get. Now what is velocity ratio? Velocity ratio we call v what arrow is equals what distance moved by effort over what distance moved by load. So here we have distance moved by what by effort over what distance moved by what by load. Now we talk about distance moved by effort is also now what as E simulator E over what simulator what L. Now another thing I want to explain here is that you can also say mechanical part can also be capital letter A over what E. Yes. So we talk about load means what capital letter L. We talk about effort means what is E. Hope you understand. Now when you talk about velocity ratio is what distance moved by effort over what distance moved by load, which was simulator E over what L. So if you check it very well, now velocity ratio effort comes up, but it's distance moved by the effort. Do you understand? Then the load distance moved by load. So you can see that it's opposite, but mechanical advantage here load by what effort. It is load. Why to call distance? So you have to pay close attention here. So there are 2 things to pay close attention. Number 3 is called efficiency. Number 2 is called efficiency. Efficiency of the machine. Do you understand? Which called the E. Which called what the E. Efficiency of the machine. Now on that the formula for efficiency here. The formula for efficiency is what is work output either what work inputs. So this is one of the definition. This is one of the formula here because we have various formula for efficiency. Work output or work input times 100 over what over 1. Just so now look at something here, because when we talk about work is equals to what force times what distance. Force times what distance, right? So there are force times distance. Please pay close attention here. Now when I talk about work output, remember output is the load you are actually overcoming. Input is the effort you are putting in to overcome the work, right? So when we talk about work output, now what do you mean? If not remember when we talk about force, when we talk about output, because we are talking about output here. Output means what? The load, right? So it's going to be load times distance moved by the what? Load. Distance moved by the load. Just so you have to put it. You have to put this in mind here. We're talking about work output. Because here we have force. The output means what? The load you are actually overcoming. So it will be load times distance moved by what? Load, right? We also send out what? L times simulator L. Very important. L times simulator what? L. Do you understand? Now, what about work inputs? Work inputs. Now, the input is the effort you are actually putting in, right? The input is what is the effort you are actually putting in. The input is what is the effort you are putting in. So it's going to be effort times distance moved by what? Effort. Do you understand? So here you can say effort times distance moved by what? Effort. Can you see that? Effort times this are what moved by the effort, which also the center what? E times what? E. So this one means what? The effort times this are moved by what? By effort. So here you cannot say that my efficiency here, which is what? E, is equal to what? L times L times what? Only by E times multiply E times 100 over 1. Do you understand? That is it. So now they see another formula here that say what efficiency is equal to what mechanical advantage over what velocity ratio times 100 over what 1. That is it. So here we have efficiency work output over work input times 100 over 1, right? From here now we have derivation to get from here. Load times this amount by load over what effort times this amount by effort times 100 over what 1, right? So we also have mechanical advantage over what velocity ratio times 100 over 1, right? Now we still have another formula that you must know. Just like efficiency is equals to what work done by the machine, but work done on the machine. So you have work done by machine, what work done on machine times 100 over what 1. Please take attention to this formula here. So the first one is what E work output over work input, right? Now this work output is what work done by the machine. Work done by the machine because the machine that is doing the work, right? Work input does not work done on the machine. So the effort you are putting is what you are putting in, work done on the machine, right? Then as you put in that effort, that work, right? Now what will happen here? The machine will now be the one to do the work. So work done by the machine. So these are formulas you need to pay close attention to when you are solving problems. Do you understand? So I want to place all the formulas, right? I want to place all the formulas. Then we start solving some keyword question. So now let's start solving question with using let's start solving question using these formulas I've given to you. So I've written them down here, right? From 1 to 5. Please make sure you take down every single formula down because I'm going to use them to solve problems. So let's see how I can use these formulas to solve different problems. Do you understand? Now before we continue here, understand that in a perfect machine or in an ideal machine or hypothetical machine, the mechanical advantage is always equal to what velocity watt ratio. So what we want to understand here is that in a perfect machine or ideal machine, mechanical advantage equals to what velocity watt ratio. Do you understand? So in a perfect machine, mechanical advantage equals to velocity watt ratio, or you can say the work output is equal to work input, or you can say work output equals to what work input. Do you understand? So in a perfect machine, it means that efficiency is equal to 100%. Do you understand? That is the machine is working efficiently to what 100%. Do you understand? But in a real sense, there's no perfect machine. Do you understand? In a real sense, there's no what perfect machine because of what frictional force. There's only frictional force acting against what the force you are putting. Do you understand? So there's no machine is 100% perfect. Do you understand? So this one is just like in case you have asked in the exam, right? But now let's start solving problem using what this various formula. Please pay close attention here. This is that a machine has an efficiency of what 80%. If the machine is required to overcome a load of 60 Newton, right, with a force of 40 Newton, calculate what the velocity ratio. Do you understand? Calculate what the velocity ratio. So the first one to do here is what write out what your parameters. Write out what you'll be given what parameters. So efficiency was given to me, which was 80%, right? Now they gave me what load, which was I can say what M, because what the load is what is 60 Newton, right? Why this was force output, right? Then my effort was given to me to be what 40 Newton. Do you understand? Now in every machine, the effort will want to be lesser than what than load. Do you understand? Because now you are applying little effort to overcome what large load. Now what they say to calculate here? Velocity ratio. velocity what ratio. Now, based on, so now let me just demarcate this one here. Now, so these are all our parameters. This is what the station will look for, right? Now, based on the question here, how do you calculate velocity what ratio, right? Now, calculate velocity ratio used from like efficiency, mechanical advantage of velocity ratio times 100/1. Or you can say distance moved by effort over distance moved by load. But the question you cannot use one here because they didn't give us distance moved by effort or distance moved by load, right? So that is the nearest formula or the formula you can make use of what mechanical advantage over velocity ratio times 100/1. No, I know what my efficiency, right? Now, what is my mechanical advantage? I can calculate my mechanical advantage using what load by what effort because they gave me what load by effort. So the first thing here I want to calculate what mechanical what advantage. MA, right? Want to calculate what mechanical what advantage equals what load over what effort. Do you understand? So if I can calculate what my mechanical advantage, I can what get what my velocity ratio. So my load is what is 60 Newton over what my effort is what is 40 what Newton. Now Newton we need to go out, right? So 60 divided by what 40. Here we have 1.5. Now, mechanical advantage does not have what units. Do you understand? So no units. So if I should apply my formula here, which is what efficiency equals to what MA over what V what R times so 100 over what 1, right? So if I should what make velocity ratio solve the formula here, here we have what V R equals to what MA times so 100 over what efficiency. Do you understand? So if I should what make sure it's formula here, here's what I'm going to get, right? So cross multiply, right? By both sides by what by efficiency. So I'm going to get that one there. So what I want to do now is to input my values. So my DR equals to what? Remember, I've calculated what my mechanical advantage should be what 1.5. So it would be 1.5 times so 100 over what my efficiency is what is 80. So I'll just say 80. So it would be 1.5 times 100 divided by what 80. So you have my velocity ratio now. Velocity ratio is what is 1.875. Now there is no units, just no unit here. So this have to want to get the first one here. Now I want to change values here. I want to try some from now. Let's say this one is what 90%, and here we have 88 Newton, and here we have 40 Newton. So go ahead and solve this up for me. Just say try one. Leave your answer at the comment section. Please, I want you to try this one here. Just pause the video and follow through here. Now, there's something between active learning and passive learning. Now, active learning is when you're actually writing everything down, then try to solve the question that's being given to you. Do you understand? So, because majority of you watching this video here, by the time you finish watching this video, you will not go back and answer some of the questions. So that's why I try as much as possible to give you questions in the video. So go ahead, pause the video and solve this question here, right? Leave your answer at the comment section, right? I will respond to that. So let's move to what question 2. So let's look at what question 2 is that the efficiency of a machine is 80%. That means the work done by a person using the machine to raise a load of 200 kg through a vertical distance of 2.0 watt-meter. So now let's solve the question together here. Solution, right? So the efficiency of the machine is what? It's already what? 80 watt%. This is at 80 watt%. Now it says determine the work done by the person using using the machine. That is a person using the machine. That is going to be the work input. Just please take class here. That is what they say that determine the work done by the person using the machine. So it's someone that is using the machine. So it's called work input. Just to raise a load, right? To raise a load of 200 kg through a vertical distance of 3.0 meters. Do you understand? So yeah, that asks to calculate the work input. Just the work input. That's what they say should look for. That's what they say should look for, right? Now, yeah, they give us loads, which they gave us load, which is 200 kg, right? Now, of course, I want to convert mass to force by multiply by by 10, right? So it is saying that my load here, which is what is 200 what kg. Now, but remember force because what mass times g. Acceleration what gravity, right? So instead I must convert this one to what to force mass times what this that what they give us g. So it's going to be 200 times what 100 times 10, which is going to be 2000 what newton. Just as so whenever you see gram, which is kg here, you have to convert to newton by multiply by what by dg given to you. Just that it's very, very important. Now they give us the distance moved by the load, which is the L. Distance moved by the load is what is 3.0 meter. So that is it. So remember, that is they asking us to calculate what work input, right? You know what this is look for. Now we have to use this formula here. So first of all, let's calculate what our work output. Remember, work output is equals to what? Load times distance moved by what? By load. So you can just say L times what? Small letter what? L, right? So it's now going to be what? 2000 times what? 3.0, right? What am I going to get? Going to be 2000 times 3. Here we have 6,000 what? Joules, which is what is work, right? So now if I should impute my value here, so efficiency now equals to what? Work output work input times 100 about 1. Now let me explain something again because I really want to understand it here. If you check the question here, determine the efficiency of the machine, which is what is 80%. Determine the work by a person using machine. So that is the work done by a person using machine is what should be what I look for, right? So to raise a load of through a vertical distance of this here. So if my load is what is this which I've converted, my distance moved by is this, right? So we are using what this formula here. Work output about work input times 100 about 1, right? So here I've calculated what my work output, which is what load times moved by load, which is going to be what 600 joules. So if I should impute my formula, if I should impute what my values here, going to be what 80 equals to what? My work output here is what is 6,000 joules over what? Work what input times 100 about 1, right? 100 about 1. So if I should what cross multiply here, what happen here? Work input equals to what? 600 joules. No, 6,000 joules times 100 about 80. So here we have times what 100 divided by what 80. So we have work input now go to be what 7500. 7500 what joules. That is it. Just and so as easy as that. That is why all these formulas are very, very important. Now let me change here. Now let me change to 65%, right? Now let us say here is what is 400, and here we have 5.0 meter. It's okay. Pause the video, go ahead and search here. Leave the answer at the comment section. It's very important. Please leave your answer at the comment section. So now let's look at the third example here. The last question in this video here. So please can you go and watch part 2, because in part 2 I want to talk about type of machine. Do you understand? So make sure you don't miss that part 2. So let's watch this one here. They say that the velocity ratio of a machine is 5 and its efficiency is what 35%. What effort will be needed to lift a load of 150 newton with the machine? So these are the options. So let's quickly solve this question. Solution. So now my velocity ratio, which is what v what arrow is what is 5, and the efficiency of the machine is what 75%, right? Now they're asking what is the effort, which is the E, that be needed to lift a load of what? 150 watts Newton, right? So now how do we calculate what? Effort. Remember, we can calculate effort through our mechanical advantage, which what? Mechanical advantage load over what effort. Just can load over what effort. So if I can really get what my mechanical advantage here, I can get, because I already know my load here. So we're going to do what? Effort is going to do what? Load over what? Mechanical what? Advantage, right? So how do you calculate what? Mechanical advantage, right? How do you calculate mechanical advantage? You can use what? Efficiency here. Efficiency equals what? Mechanical advantage over what? Velocity ratio times 100 over 1. Right? So you have to have E equals to what? Mechanical what? Advantage over what? Velocity ratio times what? 100 over what? 1, right? So if I should what? Make mechanical advantage solve a formula here. So mechanical advantage is equals to what? Efficiency times velocity ratio times 100. Can you see that? So now let's input our values here. My mechanical advantage is equals to what? My E, what is my E? 75. 75 times, what is my VR? My VR is what? Is 5 over what? 100. So what are we going to get? So going to be 75 times what? 5 divided by what? 100. So you have 3 points. So which what? My mechanical advantage now. My mechanical advantage equals to what? 3.75, right? Which is what? Is in Newton. So it does not have what? It does not have Newton. It does not have what? It does not have unit, right? So from here, because I've got what my mechanical advantage now. Remember, I say that effort equals to what? Sorry, effort equals to what? Load over what? Mechanical what? Advantage, right? My load is what? My load is 150. 150 watts. 150 watt Newton over 3.75. So 150 divided by 3.75, you have 40. So my effort equals what? 40 Newton. What is the option? The option is what? Is B. Do you see that? So this was the first part of what? Of machines. So now if I should remove here to be what? 80%, and my load here is now 200 watt Newton. Go ahead and calculate what? The effort. So pause the video, I will calculate effort, leave at the comment section. So we have come to the end of this class here. Now we still have some other video here. You can check out the playlist of our physics class.